Good evening, everybody. It's me, Miss Lee. I wanted to do an example really briefly of the algebra of the functions that I've been getting emails about from multiple students. So just as a help, hopefully this example will help us understand a little bit better about the notation we're using and the process we're following. So I started off by giving you two different functions. F of x is equal to 2x squared plus 3x, and g of x is equal to 2x plus 5. So first off, if we say we want to find f plus g of x, and this is the notation we're going to use. In this first set of parentheses, they'll say what the operation is that we want to do on those two functions. And then they'll tell us what the function's variable is going to be. So in this case, they're telling me add these two functions. When you do, your input variable will continue to be x. So what this really means is we're doing f of x plus g of x. So I wrote that. I put parentheses around both of these so that I don't forget that if there's something to distribute, I should distribute. So I have 2x squared plus 3x plus 2x plus 5. I can drop the parentheses in this situation, so I did that. And then I looked for any like terms, which is how I got 2x squared plus 5x plus 5. So f plus g of x is going to equal 2x squared plus 5x plus 5. And just in case they're asking us, this is a polynomial function, which means our domain should be from negative infinity to positive infinity. If we continued on these operations, saying we wanted to do f minus g, again, of x, this means I'm taking f of x and I am subtracting the function g of x from it. Again, I start by putting both functions in parentheses, 2x squared plus 3x minus the quantity 2x plus 5. Here we will need to distribute because this negative will change the signs of these two items. So I'm going to do that, which makes this now look like 2x squared plus 3x minus 2x minus 5. When I combine my like terms, that gives me the resulting function of 2x squared plus 1x minus 5. Again, this is a polynomial function, which means this domain should be from negative infinity to positive infinity. If we were asking you to multiply these functions together, f times g of x, again, multiply the functions, keep them as functions of x, so that just means take f of x and multiply it with g of x. So again, I put them in parentheses, 2x squared plus 3x times the quantity 2x plus 5. To do this multiplication, we're going to distribute the 2x squared with both of the items in here, the 3x with both of the items in here. So 2x squared plus 2x is where we're getting 4x to the third. 2x squared plus times 5 is where we're getting 10x squared. 3x times 2x is where we're getting 6x squared. And 3x times 5 is where we're getting 15x. Just like the other examples, if we have like terms, we should combine them. So 10x squared and 6x squared will combine into this 16x squared here. So our resulting function, if I multiply these two functions together, is this polynomial function, 4x to the third plus 16x squared plus 15x. Again, since it's a polynomial, we expect its domain to be from negative infinity to positive infinity. The last operation we could be doing would be division. So f divided by g, again, I want this to continue to be a function of x. So this is telling us to take f of x divided by g of x. So when I do that, f of x, as we recall, was 2x squared plus 3x to begin with. G of x was the function 2x plus 5 to begin with. For this particular function, we cannot simplify because we don't have common factors across all four of these terms. This function is a rational function, which means its domain will not necessarily be from negative infinity to positive infinity. As we recall, hopefully, with rational functions, we do not want the denominator to be 0 because we're not allowed to divide by 0. That does not give us a real number output, which would be a violation of our domain. So for our domain, we do not want the denominator to equal 0. So I'm going to take that denominator, 2x plus 5, and set it equal to 0 so I can figure out what value to kick out of my domain. So we would subtract the 5 to get 2x is equal to negative 5, divide by the 2 to get x is equal to negative 5 over 2. So this is where this function is going to have a problem. It's where I'm going to end up by dividing by 0, which I don't want to have happen. So for my domain, I'm going to use all real numbers. Oops, I forgot my negative on this infinity over here. My domain will be from negative infinity to negative 5 over 2, united with the set from negative 5 over 2 to infinity. I hope that helps you understand a little bit better. If you have any more questions, please let me know. I'll try and load another video if we need another example. Have a good evening. Thanks.